This is section 9.1 part B, interpreting p-values. The idea of stating a null hypothesis that we want to find evidence against seems odd at first. It may help to think of criminal trial. The defendant is innocent until proven guilty. That is, the null hypothesis is innocent of the prosecution, and they must try to provide convincing evidence against this hypothesis. That is exactly how statistics tests work. Although in statistics, we deal with evidence provided by data and use a probability to say how strong the evidence is. The null hypothesis, H sub 0, states the claim that we are seeking evidence against. So you can think of your null hypothesis as your defendant. The probability that measures the strength of the evidence against that null hypothesis is called the p-value. The probability computed, assuming that null hypothesis is true, that the statistic, such as your p-hat or your x-bar, would take a value as extreme as or more extreme than the one actually observed, is called the p-value of the test. The smaller the p-value, the stronger the evidence against your null hypothesis provided by the data. Small p-values are evidence against your null hypothesis because they say that the observed result is unlikely to occur when H sub 0, because they say that the observed result is likely to occur by chance when your null hypothesis is true. So we're saying the chance that this is only happening strictly by chance is only 1% or 5%. So we will show how to do the calculations for p-values later, but for right now we're just going to learn how to interpret them. So for the job satisfaction study described in that previous section, our null hypothesis was that that the difference was exactly 0, or there was no difference, and our alternative hypothesis is that the difference between the two scores does not equal 0, where mu is the mean difference in job satisfaction scores from self-paced minus machine-paced in the population of assembly workers at a company. Data from 18 workers gave us an x-bar value of 17 and a standard deviation of 60. That is, that the workers rated themselves the self-paced environment on average 17 points higher than what they rated the machine-paced environment. Researchers performed a significance test using the sample data and obtained a p-value of 0.2302. Explain what it means for the null hypothesis to be true in this setting. So in this setting, our null hypothesis of mu equals 0 says that the mean difference in satisfaction scores of self-paced minus machine-paced for the entire population of assembly line workers at the company is 0. If the null hypothesis is true, then the workers don't favor one work environment over the other on average. Now, interpret the p-value in context. So our p-value is 0.2302. So that p-value is the probability of observing a sample result as extreme or more extreme than we got in our sample in the direction specified by the alternative hypothesis just by chance when the null hypothesis is actually true. Because the alternative hypothesis is two-sided, the p-value is the probability of getting a value of x-bar as far from 0 in either direction as the observed value of x-bar equals 17 when that null hypothesis is actually true. What this means is an average difference of 17 or more points between the two work environments would happen 23% of the time by chance in random samples of size 18 assembly line workers when the true population mean is 0. Do the data provide convincing evidence against the null hypothesis? An outcome that would occur so often just by chance, which is almost 1 out of every 4 times, when the null hypothesis is true, is not convincing. You want a very, very small number for your p-value before you can say it's statistically significant enough to reject that null hypothesis. So the conclusion of the job satisfaction study is not saying that the H sub 0 is true or the null hypothesis is true. The study looked at evidence against the null hypothesis. So we're not saying that the null hypothesis is innocent or that it's correct. We're saying we can't reject it. So when you're saying someone in prison or when you're getting ready to go to a trial, they're not saying, like, when they reject something, it doesn't necessarily mean the person is innocent. It means they didn't have enough evidence to convince you or convince the jury that they were guilty. Failing to find evidence against H sub 0 means only that the data are consistent with H sub 0, but doesn't clearly have evidence to say that H sub 0 is true. The final step in performing a significance test is to draw a conclusion about the competing claim you were testing. We will make one of two decisions based on the strength of the evidence against the null hypothesis. We will either reject the null hypothesis or we will fail to reject the null hypothesis. In our sample result, it is too unlikely to have happened by chance, assuming that our H sub 0 is true, then we will fail to object. Otherwise, it'll be fair for us to reject that null hypothesis. This wording may seem unusual at first, but is consistent with what happens at a criminal trial. Once the jury has weighed the evidence against the null hypothesis of the innocence, they return two verdicts: guilty or not guilty, which is when they fail to reject. They don't say they're innocent, they say that they're not guilty. A not guilty verdict does not guarantee that the defendant is innocent, just that there is not enough evidence of the guilt. So likewise, a fail to reject H sub 0 decision in a significance test doesn't mean that your null hypothesis is true. For this reason, we should never use the terminology that we accept H sub 0. You should always say that we fail to reject H sub 0. So in the free throw shooter example, the estimated p-value of 0.0075 is strong evidence against the null hypothesis that the shooter's probability of making a free throw was 80%. For that reason, we reject the null hypothesis in favor of the alternative hypothesis that the probability of making a free throw is less than 80%. It appears that the virtual player makes fewer than 80% of his free throws. For the job satisfaction experiment, however, the p-value is 0.2302, and that's not convincing evidence against the null hypothesis that mu equals 0. We therefore fail to reject H sub 0. Researchers cannot conclude that job satisfaction differs based on work conditions for the population of the assembly line workers at the company. In a nutshell, our conclusion in a significance test comes down to this: if the p-value is small, you're going to reject H sub 0 and conclude that your alternative hypothesis is true. If the p-value is large, you are going to fail to reject H sub 0, and you cannot conclude that your H sub A, or your alternative hypothesis, is true in that context. There is no rule for how small a p-value we should require in order to reject a null hypothesis. It is a matter of judgment and depends on the specific circumstances. But we can compare the p-value with a fixed value that we regard as decisive, called the significance level. We write our significance value as the Greek letter alpha. If we choose alpha to be 0.05, or 5%, we are requiring that the data give evidence against the null hypothesis so strong that it would happen less than 5% of the time just by chance when the alternative hypothesis is true. If we choose an alpha level of 0.01, we are insisting on stronger evidence against the null hypothesis, a result that would occur less than 1 time out of 1 every 100 times in the long run. When our p-value is less than our chosen alpha, we say that the result is statistically significant and we can reject our null hypothesis. So if that p-value is smaller than the alpha, we say the data is statistically significant at a level of whatever your alpha is, whether that be 0.01 or 0.05 or some other level that you choose. In that case, we reject the null hypothesis and conclude that there is convincing evidence in favor of the alternative hypothesis. You do need to be cautious. Significant in the statistical sense does not necessarily mean important. It simply means not likely to happen just by chance. the statistics significance level alpha makes not likely more exact. Significance level at 0.01 is often expressed by the statement the results were significant with p being less than 0.01. Here, p stands for the p-value. The actual p-value is more informative than the statement of significance because it allows us to assess the significance at any level that we choose. So, for example, if our p-value is 0.03, it's statistically significant at an alpha level of 0.05, but it is not statistically significant at an alpha level of 0.01. When we used a fixed significance level to draw a conclusion in the statistical test, our p-value, whatever that p-value is, if it's less than your alpha, you reject the null hypothesis and conclude that the alternative hypothesis in that context is true. If our p-value is greater than or equal to the alpha level, you fail to reject the alternative hypothesis, and you cannot conclude that your alternative hypothesis is true. So, a company has developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company would like to be convinced that they are really going to last longer. Based on years of experience, the company knows that their regular AAA batteries last for 30 hours of continuous use on average. The company selects a random sample of 15 batteries and uses them continuously until they are completely drained. A significance test is performed using the hypotheses. The null hypothesis is that these new batteries will last exactly 30 hours, and the alternative hypothesis is that they'll last for more than 30 hours. Where mu is the true mean lifetime of the new deluxe AAA batteries. The resulting p-value is 0.0276. What conclusion would you make for each of the following significance level and justify your answer? So what conclusion would you make if our alpha level is 0.05? Since 0.026 is less than 0.05, we would say this is statistically significant at a value of 5%. We do have enough evidence to reject our null hypothesis in this case. Therefore, we conclude that the deluxe AAA batteries last longer than 30 hours on average. But if our significance level is at 0.01, 0.0276 is not less than this. It's greater than our statistics level, so this is not statistically significant at a 1% level. So we do not have enough evidence to reject the null hypothesis in this case. Therefore, we cannot conclude that the deluxe AAA batteries last longer than 30 hours on average. In practice, the most common used statistics level or significance level is the alpha is 0.05. When you take your AP exam, the conclusion to a significance test should always include 3 components: an explicit comparison of the p-value to the stated significance level, or an interpretation of the p-value as a conditional probability. You need to have a decision about the null hypothesis, whether you reject it or fail to reject, and an explanation of what this decision means,